Hello student, in the series of AP exam, uh, there is a rod is initially released at an angle 30 degree from the horizon. It is simple question of rotation mechanics. The question asked to find out the net torque exerted on the rod about the pivot. So we know there are two forces acting on the rod. One is the gravitation force mg and another force is normal force. But you do not need to know or write the normal force, because the torque of normal force will always zero, because normal force will always passing through the hinge point, either it is upward or any other direction. You do not need to concern about the normal force because torque of the normal force is zero. Now we come on the torque of gravitation force, torque of mg. So the torque can be written, torque equation can be written either by perpendicular force into distance, or you can either calculate it, calculate torque by force into perpendicular distance. So both way you will find the same answer. So firstly we resolve the component. That angle is 30 degree, so that angle will be 60 degree. So mg cos 60 and that perpendicular component is mg sin 60, and the length of the center of mass from the pivot is L by 2. So we can write perpendicular force is mg sin 60 and distance from pivot point is d by 2. Or you also can calculate by this force and perpendicular distance. So extend the line of action of the force and draw the perpendicular distance from the rotating point, that is a perpendicular distance. So that is L by 2, the angle is 30. So that perpendicular distance will become L by 2 cos 30. So force is mg and perpendicular distance is L by 2 cos 30. So value of cos 30 and sin 60 will be the same. So answer is same anyhow you solve it. So now check it. So mg L by 2 sin 60 is the correct answer. Now we move on the next question. In that question, uh, the mass m is attached to the spring, and the two mass m and m attached to the same spring with which has same spring constant and amplitude is also same. Now what is asked in the question is that maximum speed and maximum kinetic energy, relation between maximum speed and maximum kinetic energy, oscillation with amplitude d naught, both are oscillating with the same amplitude. So you have to compare maximum speed and maximum kinetic energy. So as we know, we can write maximum kinetic, maximum speed by amplitude and omega. So amplitude is d naught, and say I can say in the first case omega is omega 1. Okay. Now we know that formula of angular velocity is 1 upon 2 pi root k by m. So omega is inversely proportional to root m. Spring is same, so spring constant is same. But the in second case mass is double. So if we put the value of m is twice of m, so it is obvious that the angular velocity become 1 by root 2 times. Now the kinetic energy, maximum kinetic energy is written by half m v maximum square. Then the maximum velocity can be written as d naught omega 1 whole square. So for second case we can write maximum kinetic energy half, mass is double 2m, and velocity in second case you can say v naught equal to amplitude is same and angular velocity is 1 by root 2 times of initial angular velocity. So velocity is also you can say become half, so it will become d naught square omega square by 2, 2 and 2 will cancel out. So you will find the kinetic energy in the both case, initial and final case is same, but angular velocity in second case is decreased by 1 by root 2 times. So come on the question, the maximum speed is greater in trial 1 and the kinetic energy is equal in both cases. So option C will be correct. So these two example, this example is related to involving the concept of both oscillation and work energy. And previous example consists of the example of momentum and torque. Thank you.